4 volts, 2K, switch here, open, close at t equals to 0. $12 millihenry. $30K. And 2 picofarad. Pico is what? Negative 12. This is the circuit figure, whatever this figure here, reduced to a simple parallel RLC circuits after t equals 0. Determine the expression for the resistor I sub R, the resistor current I sub R for t greater than 0. So what is this current? They're not asking for VC. What's this current? Well, guess what? If I know what the voltage here, can I tell you what the current is? They're in parallel. So I sub R is really VC divided by 30K. I'm always going to find either the voltage across the capacitor or the current through the inductor. And if I'm looking for something else, I can always solve for it. The reason I'm not going to solve for this, because I don't know what I sub R is 0 minus and 0 plus. I don't know if they're going to be the same. In this case, they will be. Why? Because the voltage here happens to be the same. Not always the case. So let me look at the circuit for t less than 0. The switch was open, doesn't close till t equals to 0. So I can look at it, it will look like this. 4, 2K. The inductor is going to behave as a short circuit. 30K. The capacitor is going to behave like an open circuit. This is I sub L at 0 minus, and this is the voltage across the capacitor 0 plus, 0 minus, which is the same as 0 plus. So the voltage here is really nothing more than voltage division. VC 0 minus is going to be 4 times the resistor, which is what? 30K over the sum of them, which is 32K. 15 over 16, 4, 15 over 4. (15) divided by 4, 3.75. And that's the voltage across the capacitor, 0 plus. I will need that when I'm looking for K1, K2. That's one of them I'm going to need. I'm also going to need the current, I sub L. That's going to be 4, it's only one loop here, divided by 32K. 4 divided by 32, e to the power 3. 1.25 times 10 to the negative 4. Is that 0.125 milli? And this is I sub L as 0 plus. And I will need that to find K1, K2. Point, in case you can't see the point here. Now I need to look at the circuit for t greater than 0. The switch closes, so this is what my circuit will look like. For 2K, $12 millihenry, 30K, and what else we got there? 2 pico. If you look at the circuit, if you redraw that one, actually, I can redraw that a little bit differently. I can redraw it like this. 4, 2K, 12 millihenry, 30K, 2 picofarad. That's the same thing. Because this end, if this is my ground, this is also ground. This 2K is attached to the ground, so is this end. So I draw them a little bit differently. So which means this one here actually is going to be nothing to do with that side of the equation. I don't even have to look at it. If I do KCL at this node, this is VC here. KCL at that node. Define current going this way, that way. 0 equals I sub L plus I sub R plus I sub C. All of them, I define them leaving. Nothing going in. And if you did it right here, the same thing. So it doesn't matter if you change it to this or not. If you did KCL at that node, it's still going to be the same thing. The inductor. V equals L di dt. Hopefully you memorize these by now. Which means I equals 1 over L, the integral of V dt. So the current through the inductor is 1 over L, 1 over 12 milli. The integral of the voltage across that, to the voltage across the capacitor now. They're all in parallel. They have the same voltage, VC. The voltage across the resistor, the current through the resistor, it's the voltage divided by 30K. Plus the current through a capacitor, I equals C dVC dt. $20 picofarad dVC dt. If you divide by 20 pico, you'll have dVC dt plus 1 over 30 divided by 20 pico. 1 divided by 30K divided by 20 pico. This number is 1666666.7 dVC dt. 1 over 12 milli divided by 20 pico. This one is 4.16666, lots of them. 666 times 10 to the 12.
Six is that.
VC, lots of them, repeating.
Oh.
Equals 0. This is W squared. This is 2 alpha. W equals what? The square root of that number. It looks like roughly I got here, I want to use decimal values, 2041241. Two million 41,241. Alpha 1,666,666.7 divided by 2. Roughly 8,33333. So if I saw the correct numbers on the problem, these are my answers. Now, what do you notice about alpha and W? Alpha is less than W. If alpha is less than W, aha, we have a different story for an answer. Alpha is 8.33 times 10. Looks like I'm missing a 0. They get 8 million for alpha here. And 6 million for W with the same numbers. You can just double check these numbers here. 1 over 12 is it? 12 millihenry. And this is 30K. Right? And this is 20 pico. Just double check. 1 divided by 30,000. 1 divided by 30 e to the 3. Divide that by, 2, not 20. 2 here. Right? That's a 2 pico, not 20. Divided by 2 e to the negative 12. One, 6, 6. Let's see. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I have one more 6 here. So 16,666,666. Okay. The other number, 1 divided by 12 e to the negative 3 divided by 2 e to the negative 12. That's 13 here. So W here, let's look at W. Hate these big numbers. This is 8,333,333. Take the square root of that number. 6,454,972. So definitely alpha is bigger than W here. This is 8 million, that's 6 million. So it's the first equation again. Next time it'll be probably under-damped or correctly damped. Today is all over-damped. So my
This time alpha is greater than.
Alpha is bigger. Alpha is bigger than W, so the solution is going to be K1 e to the negative alpha plus the square root of alpha squared minus W squared T plus K2 e to the power negative alpha minus alpha squared minus W squared T. Plug them in now. So let's see what's alpha squared minus W squared. Squared times negative 1 plus alpha squared, which is 8, 333 squared. Take the square root of that one. Oh God, those are ugly numbers. Negative, what was alpha? 8 million? 8.3 times 10 to the 6. That's alpha. This will be a plus 5.27 times 10 to the 6t. We'll combine them. The other one, K2 e to the power of negative 8.3 times 10 to the 6 minus 5.27 times 10 to the 6 t. 8.3, 5.3, that's roughly what? Negative 8.3 plus 5.3 K1 e to the negative 3 million, roughly. Negative 8.3 plus negative 8.3 minus 5.3, negative 13,600,000, or somewhere like that. 13.6 10 to the 6, 3 10 to the 6. Are we getting good to these numbers? Where are they? Do we have these numbers? I'm sure we're close to them. So now I got to find what K1, K2. I have these.
I would say, I didn't mean to interrupt, but it says 3.063.
Yep, I just rounded. Yeah,
Oh,
I
you
just.
just rounded.
Yep.
Okay.
I wasn't carrying all the digits there. VC of 0, we got that number to be what? 3.75, which is K1 plus K2. That's the first equation. This is my equation here. Yeah, big numbers. I don't want to deal with all these digits there. I just rounded. Now I need to find the derivative of this twice, from the circuit and from the equation. From the circuit, from the equation, what's the derivative? Negative 3 times 10 to the 6 K1 e to the negative 3 times 10 to the 6t minus 13.6 times 10 to the 6 K2 e to the negative 13.6 times 10 to the 6t. That's the derivative from that equation. If I know what that number is equal to, that's my second equation. Let me look at the circuit at t equals 0 plus at that instant. Here's my circuit. Where is it? 0 plus. I got the inductor here. I got the resistor, and I got the capacitor. 2 picofarad. I knew the voltage here is what? 3.75. I know the current coming down here, I sub L as 0 plus, is 0.125 milli. And I know this resistor is what, 30K? That means this current here is going to be this voltage divided by that resistor. Then parallel. 3.7 divided by 30 in milli. 3.75 divided by 30, 0.125 milli. At that time, let's look at it. KCL at this node, I sub L, 0.125 milli, plus I sub R, 0.125 milli, plus I equals C dVc dt. C is 2 pico, the derivative of that. Point 0.125 is at 0.25. Move it to that side, negative. At 0. So what's the derivative at 0 plus? Negative 0.25 e to the negative 3 divided by 2 e to the negative 12. Oh, lots of zeros again. 1, 2, 3, 4, 5, 6. Negative 125 million. That's 10 to the 6 million. Plug it here. 10 to the 6 will cancel. Negative 125, the million will cancel because that's 10 to the 6 equals negative 3 K1 e to the 0 minus 13.6 K2 e to the 0. Divide by negative 3, K1 plus. What is 13.6 divided by 3? 4.53 equals 125 divided by 3. 41.7. That's my second equation. My first equation, EQ1, EQ2. See, 2 equations by 2 unknowns. I should be able to solve now for K1, K2. Let me write them down quickly. Maybe I'll multiply the top one by a minus. Negative 3.75 equals negative K1 minus K2. So I can use the elimination method. 41.7 equals K1 plus 4.53 K2. If you add them, gone. Four, 5. Oh, wait a minute. One is positive, one is negative, right? My mistake. 41.7 minus 3.75. 37.95. Equals what? 3.53 K2. What's K2? $10.75. If I know K2, can I find K1? Grab either equation. K1 plus K2 equals 3.75. K1 plus, bless you, 10.75 equals 3.75. Is that a 7? Negative 7? So what's the voltage across the capacitor at any given time for t greater than 0? It's K1, which is negative 7, e to the power of negative 3 million t, plus K2, which is 10.75, e to the power of negative 13,600,000 t. And the question for that was not what's the voltage there, what was the current through the resistor? We said divide that by what? 30K? So I sub r as a function of time now. Negative 7 divided by 30K. .23 negative e to the negative 3 million t plus 10.7 divided by 7.5 divided by 30, 0.358 milli. Milliamp. This is volts here, and that's milliamp. This is for t greater than 0. Whew.